The concentric constraint. Before we really dig into how to use it, let's be sure we understand we know just exactly what it means. Concentric simply means that we have the same center. All of these circles, 1, 2, 3, 4 of them, all share a common center point. It doesn't just apply to circles. Here I have a series of arcs that all share this common center point. Here I have a circle and an arc that have this one center point. Here are two ellipses that share the same center. We can have ellipses going all different directions, and as long as that same center point is lined up on all of them, then those are all concentric. One more to look at. We have a circle and an arc and an ellipse, all with a common center point. Let's start a new sketch just to show what it looks like when things are not concentric. Here we have two circles that are concentric with the same center point. Here we have two circles that are not concentric. This one is free to move independently of the other one, but these two are always going to move together. So these two are concentric, these two are not. If I want to make them concentric, I can just apply a concentric constraint. Let's start a new part just so we have a clean slate to work from. Start a new sketch and watch me draw two concentric circles. Click on the center point, click again, go ahead and dimension these so everything is fully constrained. Notice I drew those two circles which have the same center point. They are concentric, but I did not apply a concentric constraint. If I show my constraints, come down here to the Show All Constraints option, move that one out of the way. That's the projected geometry symbol. Come here to the middle. We see what comes up. That is the coincident constraint symbol. If we look at concentric constraint up here, see what it says about itself. It says when this constraint is applied to the center points of two arcs, circles, and ellipses, the result is the same as a coincident constraint. The concentric constraint does the same thing as a coincident constraint. If I draw a circle out here, come click on its center point, I get an automatically applied coincident constraint, which means those two circles, the center points are coincident, the circles themselves are concentric. If I start another fresh sketch, let's draw some circles out here. 1, 2, 3, 4. I can constrain center point to center point with a coincident constraint. I can constrain circle to circle with the concentric constraint. So now we ask the question, why would I use one versus the other? There are no absolute rules about when to use coincident versus concentric, but I do have a few guidelines to go by that will help you know when to use one versus the other. If I need to draw, let's say, a flat washer, let's give this a diameter, give this an inside diameter. And this is going to be the profile of a flat washer. Let's extrude that. We have a washer. When I drew that, all I did was come to the origin of my sketch, click one time to draw the first circle, click on it again to draw the second circle, and as I drew those circles, the coincident constraint was automatically applied to that center point. It would be a waste of time to draw one and then draw the other and apply either a coincident or concentric constraint to that. That's an extra step. If you're sketching from scratch, you know what you want. You just need a circle inside a circle. Draw one circle, draw the other circle with the same center point. They are automatically constrained with a coincident constraint, and they are concentric to each other. But if you are working in a sketch and you happen to have two circles, say you missed, didn't get your points right on top of each other, you can do one or the other. I can apply a coincident constraint to these two center points, I can apply a concentric constraint to the circles and get the same end result. If I can easily access either one, there really is no better or worse way to do this. You can use whichever one looks best to you and makes the most sense in your situation. But let's take a look at a couple of parts I have set up here to show when the concentric constraint is actually more useful. I have a part set up that has a curve across the top. Let's take a look at that sketch. Just a 4-inch square, but the top of this block has a 12-inch radius. I put kind of a large radius on there, just a gentle curve, so that the center point of it is way out here outside the part. So the second sketch, what I want to do is add an arc across the top of this little area at the top that is lined up to, that is concentric to the top of the part. So let's use a 3-point arc this time. If it's not already pulled up, it is the first option there, 3 points, where I draw one endpoint, the other endpoint, and then drag out a little bit to create the curvature. Now I could go down here, zoom out, come down to the bottom, find the two center points of that circle. But in this case, this is where it would be easier to just stay right up here where I'm working and use the concentric constraint to get those two arcs concentric to each other. And then let's apply a dimension to them. Now that sketch is fully constrained. Maybe I was coming in here to make a cutout through the top of that part, and that gets a consistent wall thickness. That arc to that arc being concentric to each other makes that top wall consistent thickness all the way down. Now let's look at one more part that I've already got set up to illustrate a different way that concentric is useful to us. Let me get this squared back up and take a look at what I have started already. I've got a center line drawn, and I've got a couple of curves out here. These are going to end up being the outside walls of a vase shape that's going to revolve around that center axis. But I need an inside wall. I've got the bottom drawn. I need the inside wall, inside profile of that curve. So let's again use a 3-point arc. This works especially well with the 3-point arc, because with the 3-point arc you don't draw the center point directly, but it does appear when you create it. There's one center point, or there's one 3-point arc. Draw another 3-point arc, and now I want to make this arc concentric to this one, and this arc concentric to this one. If you look at what I've got going on right here, you can see that I have 4 center points all out here in the middle together. I could come in and try to figure out which one's which and which center point needs to be constrained coincident to which other center point. This is where the concentric constraint really makes sense. I click on those two, click on those two. Now I do need to apply a coincident constraint to get these 2 points, endpoints, to match up. But now I have top and bottom arcs constrained concentric to each other. Let's come in and apply a wall thickness to all of these. Use the same thickness all the way through. Go ahead and do one more line here just to finish this out. Finish that sketch, and then we can revolve around that center axis, and that's the shape that I was looking for. If I go in and cut it in half, now I can see that wall thickness, see how it is the same thickness all the way up and down, because those arcs that I drew were concentric to each other. So again, the two main uses for using the concentric constraint rather than coincident is when you've got multiple arcs and it's hard to tell which center point is which, or if the arcs that you're working with have center points that are far away from where you're working. That's when Coincident loses out to Concentric. Bottom line, though, do what works best for you. In whatever situation you are in, you will get the same end result, whichever way you do it. Let me know in the comments if there is anything that doesn't make sense to you, or if there's something you think I overlooked. I'll do my best to help out with that. If you are ready for the next constraint, here is the link to that video. If you need to get back to the playlist that contains all of these constraint videos as well as some good introductory material, here is that link. If this information was useful to you, liking this video and subscribing to the channel would be greatly appreciated. Thank you for watching. Have a great day.